At the end of our last lesson, we learned that speed is one of the factors we need to consider, and we explain some real situations by showing before and after collision and the main transfer of the kinetic energy between objects. And we analyze some information about the relation between object speed, the amount of energy which can be transferred during collision, and we explain the scientific term of collision. We have learned that if a fast object collided with another object, it will be able to move it to a certain distance. As it moves part of its kinetic energy to the other object it hits. That's why fast objects tend to make great damages, unlike if the object speed was low. Now, is the speed the only factor that affect collision? Let's investigate like a scientist the effect of force and speed on the amount of kinetic energy that transfers between objects during a collision. We examine the effect of an inclined slope or ramp on the speed and the energy of moving objects. We measured the impact of speed on collision by changing the height of the slope. And the more the speed increases, the more the kinetic energy increases, the more the time decreases. It means fast objects has more speed and more kinetic energy and take less time. So the more inclined slope increases, the more the speed increases, the more the kinetic energy increases, the more the time taken decreases. So the speed of the moving object on a ramp increases by increasing its mass. By increasing the mass of an object that moves down a ramp, the kinetic energy of this object increases. Note, the speed and kinetic energy of a moving object on a ramp can be increased by increasing the angle of the ramp or the slope and increasing the mass of the object. So as we can see here, moving balls, the one that travel first has the greater mass and the greater speed. So again, by increasing the mass, the force increases, the speed increases, and the kinetic energy increases, and the damage increases. What happens to objects when they collide with another object? We have learned that the energy transfer between objects during the collision and the greater speed and mass of a moving object, the greater kinetic energy this object has during a collision. When an object collides with another one, it transfers all its kinetic energy or just some amount of it. Does the energy disappear in a collision? Let's see together a simple device, we call it Newton's cradle, that has a special way of moving. As when we pull the first ball and we let it go, the balls start moving back and forth. Why the balls in the middle didn't move? Do the balls will keep moving or they will stop? When the first ball at one end released, the balls in the middle hardly move, but the outer last ball is at the opposite end is pushed away from the frame. It's a good demonstration of energy transfer. The ball that you pull has potential energy, which converts into kinetic energy and causes it to collide with the next ball. The energy is then transferred down the line. It's only when the energy is transferred to the outermost last ball, to the opposite end, that there is a significant movement, because it doesn't have another ball to transfer its energy to. When we pull back the first ball, it means that we do work. So it stores potential energy. And once we let it go, the energy converts from potential energy into kinetic energy. Then the ball transfers its kinetic energy to the second ball. Then the second ball keeps transferring till it reaches the last ball. Then the last ball didn't find any object to hit, so its motion will be free and rises up, storing the kinetic energy in the form of potential energy as it's going up. Then again it falls down, transforming the potential energy into kinetic energy, repeating the same sequence again. What if we pull two of the balls, and what's going to happen? Why is the energy here able to move two balls at the other end? Does this only happen in Newton's cradle or also in our daily life? What would happen if a moving car collided with a stop sign, but not all the kinetic energy transfers to the sign? Where do you think the rest of kinetic energy goes? At the time of collision, you will hear a bang, which resulted from the sound energy. Also, the friction of the car with the sign will generate thermal energy or heat energy, and they are forms of the kinetic energy. That means that the car kinetic energy didn't all disappear in the collision, but instead it transformed into different forms of energy. So like the car and the stop sign collision, some amount of the kinetic energy the ball have transforms into different forms of energy, like sound energy that you hear when the balls are colliding, or the generated heat from the friction between the balls, as well as the air resistance as they pass through the air. Some of the energy is lost as sound energy and as friction between the strings and other parts. At the end, as the kinetic energy continues its transfer between the balls, while it transforms into different forms of energy, the cradle reaches a point, then it stops moving, because the balls loses all their kinetic energy, but the energy doesn't disappear or lost. The amount of energy before collision equals the amount of energy generated after collision. Any moving object has kinetic energy, and the amount of kinetic energy depends on the object's mass and speed. That's why when we move two balls, so we have two kinetic energy of two balls, ball 1 and ball 2. So two balls with two kinetic energy will move from the other side. If you leave the moving balls of Newton's cradle long enough, their kinetic energy decreases gradually until they stop after lots of collisions. Energy is conserved during collision, so it cannot be destroyed, but the amount of energy before the collision is equal the amount of energy after collision. So let's apply what we learned from the Newton's cradle on cars collisions. The first thing we should consider in a collision is the kinetic energy. And as we learned, it depends on the speed and the mass of objects. So if we have two cars with different masses, the car with the bigger mass will have the most kinetic energy. But if the car's mass is equal, so the one that has greater speed, the more kinetic energy it has, causing more damage and producing more sound and more heat. Now we can investigate a real car crashes and connect what we have learned to real life problems or to different STEM jobs like the jobs of crash investigators, to analyze a group of different crashes to know the real reasons and factors that lead to the collision. The car makers used the data recorded by crash investigators during their investigation. They think of different factors that keep the passengers safe, to redesign a safety features for car drivers. The investigators' first task is to measure things at the accident scene, like the damage of cars and where they ended up in the crash. This means that they might use photos or videos not to block the road. They start to record the data and the damage for each car. Do the cars have the same amount of damage, or damage is on only one car, as the size of damage can indicate the force of collision. Also, they identify the place or location of cars after collision and how far did the car move. That could be evidence of the speed of the driver of the two cars used and the mass of the two cars. They also scale the mass of the cars. Larger mass, of course, cause more damage impact. Also, they compare the data manufacturers before and after collision to measure the amount of force that can cause damage to the cars during collision. So to summarize their tasks, number 1, they measure the damage of the cars and where the car ended in a crash. Number 2, they measure the mass of the car by a scale. Number 3, measuring the force using a reference material of the manufacturer. Then they analyze problems, investigate reasons, and try to know the cause and effect. We will analyze scenarios for different collisions, accidents. Next. Crash site scenarios. The first scenario, side collision. Before the crash, the red car was moving straight and the blue car is moving to the right side. After the crash, the red car will change its direction to the right due to the pushing force of the blue car, meaning the arrow is drawing to the right. The second scenario, front collision. The red car was driving through the intersection legally, but the blue car was driving in the wrong lane, in the opposite direction, also driving faster than the red car, which drives less than the specified speed. So we conclude that faster car has more kinetic energy and pushing force, so the collision occurred in the front of the two cars. So we expect that the blue car transfer its kinetic energy to the red car, pushing it and return walk in the opposite direction. Today we learn what happened to objects when they collide with one another and the main transformation of energy and the different factors that affect the severity of collision, speed, mass, and kinetic energy. Finally, we are reached the end of this concept. Thank you and see you next time.